Welcome to Saitechinfo channel, my dear students. In this tutorial, I will be explaining about the cleavage of bond and metamerism in organic compounds. Chemical reaction and physical reaction. Let me take a chalk piece like this. When I break it, now it is going to be two pieces, and I have not broken the chemical bond, I have broken only the physical bond. So it means the physical force of attraction, that is the van der Waals force of attraction, that is the intermolecular force of attraction, has been broken. So that is physical reaction, that results in physical reaction, and the properties exhibited by this physical reaction or physical bond cleavage is called physical property. So what are physical properties? The appearance, color, then boiling point, melting point, etc. Whereas, let me take sodium chloride crystal and hammer it and make it as a powder. Can we claim that it is chemically broken? The chemical bond of sodium and chlorine has been broken? We cannot say like that. So, let me discuss further in this. Chemical reaction where chemical bond is broken and it results in the formation of new products. And this cleavage of bond, breakage of bond, we cannot break the bond, we have to use the language, the word cleavage. So let us cleave, it indicates the soft nature of the bond. So it cannot be hammered. So for breaking the chemical bond, you cannot use the hammer, is it not? So here the chemical bond is cleaved in two ways. One is homolytic cleavage, another is heterolytic cleavage. Homolytic cleavage can also be called homolysis, and heterolytic cleavage is heterolysis. Homo means the same, hetero means different. Homolysis means cleavage. So this is the even cleavage. For instance, chlorine, it has got the covalent bond, and because of the that is the influence by the photons, it can be cleaved also. So they result in free radicals. So free radicals are the products of homolysis. So chlorine, it involves, the chlorine molecules involve two electrons here. So this covalent bond is cleaved here, where the chlorine atom with its own electron, that is odd electron, and this chlorine with odd electron, they are called free radical. So an atom with odd electron can be called free radical. In the case of sodium chloride, because of the difference in the electronegativity, here both chlorines are of same electronegativity, whereas here sodium has less electronegativity, so it can be called electropositivity. And here the chlorine has more electronegative, so being the non-metal, it is more electronegative, and sodium being the metal, electropositive, that is less electronegative. What do you mean by electronegativity? It is the tendency to release the electron. So sodium electropositivity. So sodium becomes Na plus by releasing one electron, means that is the electropositivity of the metal. And what about chlorine? It undergoes an withdrawal of electrons to become chloride ion, right? So when the cleavage takes place in this way, in an uneven manner, then it is called heterolysis. So we can call the ions are the products of heterolysis, and free radicals are the products of homolysis. Let me consider methane. It is subjected to photochemical cleavage. So by passing chlorine, what happens? It becomes a methyl chloride, and with the removal of HCl. Initially CH4, and this Cl2 is initiated into the formation of chlorine, chloride, chlorine free radical. It is because of it's called chain initiation. So here it is subjected to the homolysis only because of the formation of free radical. Now let us consider the sodium hydroxide where ions are resulted. So this is called sodium cation and the hydroxide anion. So the bond between sodium and the hydroxyl ion is unevenly broken. So that has resulted in Na plus and OH minus ion. So ions are the products of heterolysis. Now let us discuss about metamerism. The metamerism means, that is, let us consider for instance ether. So this is called methoxyethane. We had to consider the long chain hydrocarbon. So ethane is a long chain hydrocarbon, and where oxy is linked with the methyl group. So methoxyethane or methyl ethyl ether. That is the common name, and not common name, trivial name. Now suppose if the ether is like this C4H10O, in this case CH3CH2O, CH2CH3, diethyl ether, whereas here it is methyl propyl ether. Here, because of the change in the bulkiness, that is the nature of alkyl group, it is changed. So we can also call the bulkiness or nature. So by which of the change in the nature of the alkyl group, we are able to get such type of what? Metamerism, that is isomerism, with the change in the nature of alkyl group. And this can also be exhibited in the case of ketones also. Here 2 hexanone, this is 3 hexanone, where the CO group is in the second position, whereas here CO group is in the third position, and you can see the change in the nature of the methyl group, alkyl group. Here methyl, here buta, whereas here it is propyl and here ethyl. So when we want to explain the metamerism, you should know something about the functional isomerism also. Functional isomerism, or the isomers resulted, is a phenomenon of formation of isomer by the change in the nature of the function group. So here let me say C4H10O, and we can write this as C4H9OH and C2H5O, C2H5. In this case oxy linkage is here, whereas here hydroxyl group. So this is alcohol, this is ether, and that's why they are called, because of the difference in the nature of function group, they are called functional isomers. And among the functional isomers, it can exhibit the position and the chain isomers like primary, secondary, tertiary, and isobutyl alcohol also. Whereas in this case, we have the metamerism, for instance diethyl ether, whereas here methyl, methoxypropane, this is ethoxyethane, okay. And even the nature of propyl group can be changed here. So this is isopropyl, this is methyl. So these are all metamers, right? Okay, thank you.